Imagine if you could live in a world where dinosaurs never went extinct, or where you are the president. Sounds like a plot of a sci-fi movie, right? But what if it's not just fiction? Welcome, dear listeners, to a concept that has sparked curiosity and ignited imaginations for years: the multiverse. This is the idea that our universe isn't the only one out there. It suggests that there might be a multitude of universes, each with its own laws of physics, its own history, and maybe even its own version of you. For centuries, humans have been fascinated by the idea of alternate realities. From ancient mythology to modern-day science fiction, the concept of a parallel universe has always held us in thrall. Now scientists are beginning to explore this idea in earnest. So strap in, folks. Let's dive into the world of alternate dimensions and parallel universes. To understand parallel universes, we need to start with the basics. The universe as we know it is a vast expanse that contains all known matter and energy, including galaxies, stars, planets, and everything in between. It's a three-dimensional space expanding in every direction, where time serves as a fourth dimension. This four-dimensional continuum is what we call space-time. Now let's imagine our universe as a bubble. This bubble is expanding, but it's not expanding into anything. Instead, the very fabric of space-time is stretching. This concept might be a tad tricky to grasp, but it's fundamental to our understanding of the universe and, by extension, the theory of the multiverse. The multiverse theory, as mind-boggling as it sounds, proposes that our universe, our bubble, is not the only one. Instead, it's part of an infinite ensemble of universes, each existing in its own bubble. These universes, or bubbles, could be endlessly inflating, creating an ever-expanding cosmic quilt, so to speak. This idea is not a newfangled concept, but has its roots in the interpretations of quantum mechanics and the inflationary Big Bang model. Going back to the early 20th century, physicists Erwin Schrödinger and Werner Heisenberg introduced the world to quantum mechanics. This theory shook the foundations of classical physics, suggesting that particles could exist in multiple states at once, only settling into a single state upon being observed. This idea, known as superposition, has been interpreted by some as evidence of parallel universes. Fast forward to the 1980s, and we have cosmologist Alan Guth proposing the inflationary Big Bang model. This model suggests that in the moments after the Big Bang, the universe went through a rapid expansion, which could have spawned countless bubbles or universes, each with its own laws of physics. So if the multiverse theory holds, we're just a tiny speck in an endlessly inflating sea of universes, each with its own laws of physics. Now that we've grasped the basics, let's explore the different types of multiverses. Our guide, physicist Max Tegmark, has proposed a framework that categorizes multiverses into 4 distinct levels. The first level of the multiverse is an extension of our universe. Picture this: our universe, as vast as it is just one bubble in an infinite cosmic ocean. Outside our bubble, there are countless others, each representing a separate universe. These universes might have different physical laws or different outcomes of events, but they're all part of the same infinite space-time. Moving on to the second level, things start to get a little more abstract. Here, the multiverse isn't just an extension of space-time, but a separate entity entirely. These universes may have different fundamental constants and physical laws. Imagine a universe where gravity repels instead of attracts, or where time flows backwards. This is the realm of level 2. The third level of the multiverse takes us into the world of quantum mechanics. Here, every possible outcome of a quantum event spawns a new universe. Let's say you're about to flip a coin. In our universe, it lands on heads, but in a parallel universe, it lands on tails. Every decision, every random event creates a branching path of realities. Finally, we arrive at the fourth level, the most abstract of them all. This level proposes that all mathematical structures exist physically in some universe or another. It's an idea that blurs the line between mathematical truth and physical reality. So there we have it. From infinite space-time bubbles to quantum branches, from alien physics to mathematical realities, these are the 4 levels of multiverse as proposed by Tegmark. Each level proposes a different concept of parallel realities, leading us deeper into the rabbit hole of the multiverse. Now let's ponder the implications of these mind-boggling theories. Imagine a reality where the laws of physics as we know them are turned upside down. A reality where time flows backwards, or where gravity pushes rather than pulls. This is the tantalizing promise of the multiverse theory. It suggests that our universe, with its particular set of physical laws, is just one of an infinite number of universes, each with its own unique characteristics. It's like an infinite cosmic lottery, with each universe drawing a different set of physical laws. This concept challenges our understanding of reality in profound ways. If the multiverse is real, it means that everything we know, everything we've experienced, is just a tiny slice of the cosmic pie. Our universe, vast and complex as it seems, would be but a single bubble in an endless cosmic foam. Moreover, the multiverse theory paints a picture of infinite possibilities. If there are infinite universes, then every possible event is happening somewhere. In some universe, you might be a rock star. In another, dinosaurs might still roam the Earth. There could be universes where time travel is a reality, where we could meet alternate versions of ourselves, where the impossible becomes the everyday. Of course, these are just speculations. The multiverse theory is still a topic of heated debate among scientists. It's a theory that pushes the boundaries of our understanding, that challenges us to reconsider what we think we know about the universe and our place in it. But isn't that what science is all about? Pushing boundaries, challenging assumptions, exploring the unknown. Whether the multiverse theory is proven or disproven, it's already served a valuable purpose. It's sparked our curiosity, piqued our imagination, and pushed us to look beyond the familiar confines of our universe. In the grand cosmic scheme of things, we might be tiny, insignificant specks, but we're specks with a limitless capacity for discovery, for wonder, for exploration. The possibilities are as infinite as the universes themselves. So, are these alternate realities real, or just a figment of our imagination? The current scientific consensus on the multiverse theory is, to put it mildly, unsettled. The theory itself is an astonishing testament to human curiosity, a bold leap into the realm of what-ifs and could-bes. But as of now, it remains just that, a theory. There's no empirical evidence to back it up, no tangible proof of these other universes existing alongside our own. It's a concept that sparked fierce debates in the scientific community, with voices of both unbridled enthusiasm and staunch skepticism echoing through the halls of academia. But despite the lack of concrete evidence, the idea persists. It's a tantalizing prospect, isn't it? An infinite number of realities, each one a different spin on the universe we know. Whether real or not, the concept of parallel universes continues to captivate us, pushing the boundaries of our imagination and understanding of reality.